Let us now work an example problem in Excel. 5.14. In a manufacturing company regularly conducts quality control checks at specified periods on the product it manufactures. So historically, the failure rate of LED light bulbs that the company makes is 5%. So failure rate is 5%. Now we want to compute probability of failed LED lights. So a failed LED light here is defined as the success in the binomial experiment. Okay, so pi will be 5%. Now we select a random sample of 10 LED lights and we want the probability that none of them are defective, exactly one is defective, two or fewer, or three or more. Okay, so we want these probabilities. So let's go to Excel. So here in our experiment, we are talking about LED light bulbs, and let's define success. Here is LED light bulb fails. Now we have number of trials is 10, pi is 0.05. Now problem A, question A is none of the light bulbs are defective. So X is 0. We want the probability X is 0. Okay. Now here is the formula for binomial probability. So we want n combination NCX, so n combination of X. So n is 10, X is 0. So 10 combination 0, and then pi to the power of X, and 1 minus pi to the power of n minus X. Okay. So here Excel has COMBIN combination. So the number is 10. So let's make that absolute reference. So we'll be able to copy this function later on. Comma X. So this gives us the combination 10 combination 0. Now pi to the power of X. So pi is here. And let's make that absolute reference to the power of X. Then we have 1 minus pi to the power of n minus X. So that is n minus X. And n here must be 1 minus pi. Pi should be absolute referenced, and n should be absolute reference as well. Okay. So now if you multiply these three, so combination n combination X times pi to the power of X plus 1 minus pi to the power of n minus X. So that gives us the probability that X is equal to 0. Exactly 0 bulbs fail. The next question is exactly one of the light bulbs is defective. So here we want exactly one, and now what we want here is 10 combination 1. Okay. Now, since we have set up the formula correctly with absolute references, you can copy that and you would get, okay, so 10 combination 1 is what you would get. Now the rest of them are, again, we have set the formulas up correctly, so all you have to do is to simply copy those formulas down here and you get the answer. So here is pi to the power of X, 1 minus pi to the power of n minus X, and then product of those three. Next question is 2 or fewer. So if you want 2 or fewer, so we have X is 0, 1, or 2. We actually have 0 and 1 already computed, and all we have to do is to compute 2 and we will have it. But let's do each of them separately. So we want to compute these three probabilities and then add them up. So here we have 10 combination x and pi to the power of x, 1 minus pi to the power n minus x, and then we have the probability of x. So we already have these set up correctly, so we can just copy those four items down here. And of course the first one is the same as A, the second one is same as B, the third one is for x equal to 2. So this is 10 combination 2, okay, and then pi to the power of 2, and then we have 1 minus pi to the power of n minus x, and then the product. So now the probability of x equal to 2, the probability of x less than or equal to 2, okay, so that's what we want. So that will be the sum of these three probabilities, x equal to 0, x equal to 1, x equal to. Now we can also use Excel binomial function here. So we have binomial distribution. Okay, binomial distribution, okay, you have number and trial. So number here is that, number of trials is that, so that should be absolute referenced. Okay, and probability of success, that's that, again that should be absolute referenced. Now if you want individual probability, then you put 0. If you want cumulative probability, you put 1, true or false. So 0 represents false, that is we want individual probability. If you put 1, you'll have cumulative probability. So if you then copy that, so you get exactly the same numbers like there. So probability of x less than or equal to 2 will be the sum of these. So if you sum these three values, then you get the probability. The same, you get the same probability, of course, as before. Okay. Now if you, instead of finding the individual probabilities, if you want to find the cumulative probability directly, then you simply use binomial distribution. Okay. Now use 2, x equal to 2. Okay, you don't have to do 0 and 1. And then you have your n and pi. And then say 1 for cumulative distribution, true. So then you get the cumulative probability, that is 0, 1, 2, all three of them added together, and you get the answer in one function itself. So the last argument in binomial is whether it's cumulative probability or individual probability. Now these 3 or more of the LED bulbs. So 3 or more would be, okay. Now there are a couple of ways in which you can do this. Okay. You can compute 3 or more will be like 3, 4, 5, 6, 7, 8, 9, 10. So there's lots of probabilities for you to compute and then add them up. Or you can do the complement. If you want 3 or more, then that is the opposite of 0, 1, and 2. So if you can compute 0, 1, and 2, which we've already done, so we can do 1 minus that 0, 1, and 2. So it'll be, this is simply 1 minus the probability of x less than or equal to 2, which we've already computed. Let's also compute the expected value of x, variance, and standard deviation. Expected value of x is what? N times pi. So here is n times pi. That's the expected value. The variance is n times pi times n times pi times 1 minus pi. That's the variance. When you take standard deviation, you need to do a square root of that to find the standard deviation. So that's binomial probability.